Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll take a look at literal equations involving linear equations. A literal equation is an equation that has more than one variable in it, and we're going to treat all the variables except for one as if they were constants, and we're going to solve for one variable in terms of the other. So the problem listed as number 13 here is an example of that. It says solve for y, the equation 3x plus 2y equals 18. We're going to treat the y as the variable in the problem, and the x is like it's a constant. So think about what you would do if you just had this equation instead. 3 plus 2y equals 18. We've got the one variable term 2y on the left-hand side. We want to move the constant term to the other side and then finish by dividing. We're going to use the same approach here. I'm going to move, once I have the single variable term on one side, which I do, I'm going to move all the other terms to the other side of the equation. So I'm going to subtract 3x from both sides. 3x minus 3x is 0, so I'm left with 2y equals, and then I can either write 18 minus 3x, or I could write negative 3x plus 18. I can't combine the two of those because one term has x, the other one doesn't. I'm going to write 18 minus 3x here, but you could also have written it this way. 2y equals negative 3x plus 18. Same thing. Now to isolate y, I need to divide by 2 on both sides of the equation, and I'm done. I can't divide 2 into both of the terms in that numerator, and so this is as far as I can go. Y equals 18 minus 3x over 2. Now you may see at some point an advantage to writing this as y equals 9, 18 divided by 2, minus 3 halves x, or y equals negative 3 halves x plus 9. But in terms of just solving for y in terms of x, that is good enough. In the next equation that says solve for t, the equation is I equals p RT, and that's multiplication, p times r times t. This is a formula for interest, calculating interest. The variable is t, and so there's only one term with t, and it's on the right hand side. I need to peel away what's attached to t, and here that's p and r, and because they're both being multiplied by that, I can divide both sides by p and by r. P divided by p is 1, r divided by r is 1. That leaves me with just t on the right hand side. On the left hand side, there's nothing I can do other than write what I have, I over pr. Now, when you're asked to solve for a variable in a linear equation, typically we like to write that variable first. So I'm going to switch the sides here, just rewrite it as t equals I over pr. And basically what we have here in this formula is a new formula for calculating the time if you knew the interest, I, the principal, p, and the rate, r. The next two are a little more involved because they both have more than one term that contains the variable we're solving for. And to solve these, we're going to have to use a skill called factoring, which you're familiar with, but we'll talk about again. It says solve for h. Oh, I erased what was there. There was a p there. Sorry about that. No, that's not right. There was an s that was there. It was surface area. I erased it. Sorry about that. So s equals 2lw plus 2lh plus 2wh. Notice I wrote my l cursive so that I don't confuse it with the number 1. All right, this is a formula for surface area of a box, and I'm trying to solve for h, and h is in the last two terms, so I want to keep those together, but I want any term that doesn't have h moved to the other side. So I'm going to begin by subtracting 2lw from both sides. That leaves me with s minus 2lw on the left equal to 2lh plus 2wh. I need to write the right-hand side as h times something. so that I can solve by dividing. And the way that I can do that is by factoring out the common factor of h. You can think of it basically as undistributing. If I write the h in front of a set of parentheses, what I need to figure out is what should be in that parentheses, that if I distribute the h through to each term, it will give me what's above it. And that's going to be 2L plus 2W. I'm basically pulling that h, undistributing that h from those two terms. The left side stays the same. It's still s minus 2LW. And now I've got the right-hand side written as h times some expression. I can divide both sides by that expression. So I'm going to divide by 2L plus 2W. And I've got my solution. I've got h isolated. Again, I'm going to rewrite it so that it's on the left-hand side. H equals s minus 2LW over 2L plus 2W. One more similar type of problem. It says solve for x. I've got 8a minus bx equals 5a plus cx. So this time the variable I'm solving for has a term on each side of the equation. I need to collect those together first. Because the bx is negative, I'm going to add it to both sides. So I'm going to add bx to the left and right sides. That leaves me with 8a equals 5a plus cx plus bx. And if you want to write those in alphabetical order, go ahead. You can write 5a plus bx plus cx, and that's okay too. I've got all the variables on the right-hand side. I need to move the term that doesn't have x to the left-hand side, so I'm going to subtract 5a from both sides. 8a minus 5a is 3a equals cx plus bx. I'm going to keep them in the order I had them. Now I can factor out x. 3a equals x times c plus b. And I can finish by dividing both sides by c plus b. And I'm going to finish by rewriting this with x on the left-hand side. So x equals 3a over c plus b. Now I've got that equation rewritten in terms of x. X equals some expression involving the other numbers and variables in the problem. All right, that is it for this section on linear equations. The next set of videos will move on to a different main topic.